Yeah, today I will be speaking about a POC solution that we have built using GenAI. The main focus was to automate some of the manual tasks of our DBA activities. So we are leveraging some of the foundation models and generation AI to build this tool. So for today's agenda, we'll be starting with introduction. We'll understand what is the objective behind developing this solution. Then to better understand the solution, we'll also go with some basic concepts used to develop this solution. So we'll go through the use case and some of the components used to build this solution. And then we'll be going through the detailed architecture. And we'll also have a demo on this tool. So if we have time, we'll also see the next version of this tool, what are the next steps we want to develop in this tool. So coming to introduction, so our objective was to develop a solution where we wanted to automate some of the manual tasks that we perform as a DBA every day, so that our operational efficiency would increase. So this tool has three components. One is a chatbot, which answers to all your queries as a DBA. And also there are two interfaces where it interacts with the database and get the real-time data from the database and performs some health checks. So it also recommends query tuning based on the query plan. So these are all recommendations that you can get from this tool, and you can implement it in your database. So before we jump into knowing the architecture of this solution, so let's understand what are the building blocks and what are the basic concepts used. So GenAI again is built on top of what are vectors and vector embeddings. So what is a vector? Vector is how you represent particular subject or an entity in a multidimensional space. So each dimension of a vector represents specific character of that particular subject. So we actually convert the text into these vector embeddings. These are nothing but array of numbers. So each dimension in this number represents a specific characteristics. So this is the format which all your machine learning models can understand. So once you convert this text into embedding, you have two capabilities. One is to do a semantic search, and another one is you can also perform arithmetic operations. So better to understand with an example. So here we have four embeddings. So each embedding is of a five dimension. So there are two categories of embeddings here. So one represents sports and the other ones are belonging to insects. But you can see the spelling of cricket is almost same. So each value here, let's take an example of cricket and then the baseball. The first two dimensions, let's assume that it represents rules of the game. Second one represents that it involves bat and ball, right? If you look at the baseball, again, these values are almost identical. Similarly, so it means that the characteristics of these dimensions are almost same. So when you look at the insects vectors, they are also identical with their own characteristics. So when we place these embeddings in a two-dimensional graph, although these are finite-dimensional, we are representing it in 2D just for understanding. So you can see that likely vectors are close by. So when you do a semantic search or a nearest neighbor search, you can get the closely associated vectors. So we are also using large language models or foundation models. So these are deep learning techniques or systems that are trained on enormous amount of data. So you can think of LLMs as a person who has read millions of books. You ask him any question and he can answer to any topic. So these models use deep learning techniques to get trained on this enormous amount of data. So these neural networks have capability to understand the patterns and also the relationship between the data on which they are getting trained on. So nowadays, large number of AI applications are using LLMs. So you can, for example, you can build a question answer chatbot, or you can build a summarization tool which can take large articles and summarize what's there in that article. You can also build tools like translators which can convert one language to other language. So in today's solution, we are using two LLMs. One is from Anthropic, which is called Anthropic Claude 3 Sonnet. And to convert our text to embedding, we are using Amazon Titan Embed. So although these LLMs are very powerful tools, systems, so they have some limitations. So they can sometimes generate inaccurate responses. So these limitations mainly occur because when you train these LLMs, you train till one point of time, so it may lack the latest data. So other limitation would be, mostly these are trained on public platforms. Any data which is available on public platforms, for example, Wikipedia, or it can be your Git repos, public repos in GitHub. So it might lack domain-specific information. So there are few methods by which we can overcome these limitations. So let's talk about few of them. One is prompt engineering. So prompts are nothing but what is the query you are sending it to the LLM to get the desired output. So you can also send some context along with your query. So this context can be additional information or instruction to the LLM model. So for example, context can be a detailed instruction on how to solve the problem and give the response, or it can be a conditioning where you will say how the output should look like, whether it should be a JSON or it should be a tabular format of output, etc. So it has some methods, and let's talk about few. So one-shot prompting is like you will give a example question and an answer. So it will refer to that example question and answer. It will understand how it should respond. So other one is few-shot prompting. Similar to one-shot prompting, you will give more questions and more examples. So there is an advanced prompting like chain of thought prompting, where you will give large number of steps. So each step will be dependent on each other. So output of first step will be used in the next step to answer the question. So although prompt engineering helps you to get the desired output in certain format or with a certain way of solving the problem, but it still doesn't solve the lack of latest trained data of an LLM. So for that, we are using a technique called RAG, which is retrieval augmented generation. So this is a technique where we supply external data source to your LLM. So typically, these data sources are vector databases which store your data along with their embeddings. So what we do is we actually query these vector databases. So let's break these three terms. Like, let's understand what is retrieval. So retrieval is something where we do our nearest neighbor search from the vector databases. So we retrieve the useful information and embed and augment the prompt with this information and send it to LLM to finally generate the desired response along with the latest data. So there are a lot of different vector databases. For example, you can use Pinecone, you can also use OpenSearch, and now you can also use PostgreSQL. So by using pgvector extension. So all you need to do is create a pgvector extension, and after you install, you just have to use this create extension command to create the vector. So once you create this vector, you will get a data type called vector, by using which you can store embeddings. So pgvector extension also gives you two abilities. One is to do an exact search and also do a nearest neighbor search. So nearest neighbor search is what we will use, and this capability also uses few operators. So two of the most popular one are Euclidean search and cosine distance search. So cosine distance search is like in the graph what we saw. It's the angular distance between these two vectors in the graph. Euclidean distance is the linear distance. So once you store these embeddings in the vector DB, pgvector also gives some capability to enhance the performance using IVF flat and HNSW indexes. We'll not dive deep into these indexes, but all you need to know is HNSW indexes are more optimal compared to IVF flat. Just a quick example, we created an extension here, created a table called subject, and we have inserted the 3 vectors from our previous example. And using a cosine distance operator here, we are just looking for nearest one result, so which we got as cricket. So I should have also selected the embedding to just ensure that it's outputting the sport. So we are querying it with the baseball embedding and finding the nearest subject. So as we have understood some of the concepts, now let's understand the actual solution and the background of the solution. So as a DBA, we perform certain tasks, like we actually identify the slow queries, we actually generate plans, we go through the plan, each and every line of the plan, and we come up with some recommendations and tuning recommendations. And we apply the tuning, and then we come up with some optimized query. So we also do some of the tasks, like we have to log into the database, check all the catalog tables and stats of a database, and come up with certain findings and run some commands, run some maintenance commands. And most of the time as a DBA, you have to remember a lot of commands, memorize a lot of commands. So these are some of the challenges, and sometimes when you don't remember something, you will be referring to multiple blocks and multiple documentations. So we are trying to build one solution which can cover some of these manual tasks. So our objective was to use GenAI model, 2 LLM models which we discussed, and generate and come up with a tool which can automate some of the things what we discussed in the earlier slide. So our tool will have an assistance which will act like a chat bot, where you can ask any question regarding the database and it can answer. It internally uses a RAG, which is a managed knowledge base, and also we are using 2 LLMs from Anthropic and Amazon embedding for creating the embeddings. So it has the ability to connect to the database and fetch real-time data, and also send that data to LLM to get recommendations. So in our code, we'll be using LangChain framework as well to capture the contextual information. So we also have a front end to actually manage the vector database. So this is a Python-based tool. Along with LLM and LangChain framework, we're also using Streamlit framework, which is a Python-based framework to build AML apps. It mainly launches web server with an interface. It's having least learning curve as well. Is this visible? Okay. So on the right-hand side is where we are creating the vector database. This is fully automated. So we are uploading the documents, and these documents will be uploaded to a document repository, which is S3 bucket. Once the files are available, it can automatically pick the file. It can break those files into chunks and convert them into embedding and store in the vector database. On the left-hand side, we have 3 modules. One is chat assistant, which will answer to the user queries. There are 2 more modules. One is to connect to the database, extract some information, and send it to LLM, and query the vector DB as well to get the recommendations. We have one more module which will help us to tune the query according to the query plan. Again, it has two abilities. One, it can directly read the plan, or you can also give the query. It will connect to the database and get the plan and then generate recommendations. Yeah, so this is some same thing what we discussed. Yeah, so we'll go through the demo as well, and we'll just check the code of one of the module, so for the time constraints. So for this demo, I will use a dummy database on my local system. So it is having a dummy schema with these schemas, and each schema has certain tables. So we will launch the tool using Streamlit run. So it's already running. So once you launch, it will give this interface. So let's see the knowledge base as well. So for demo purpose, I've already created the knowledge base. So you will basically browse and select all the files you need to upload to S3. It will automatically upload once you click on select the files. So sync the knowledge base will actually chunk these files and create the embeddings and store it in the vector database. So I'll just have a look at how it looks like. So you can see these documents were chunked. You can see the actual data, also the metadata. Metadata is a JSON which stores from which path the record was picked, and this is actually embedding the embed column. So this can, at present, this table is able to support around 1024 dimensions. So let's see this interface. So here it takes two input types. One is query and the plan. I can show one example. So let's check the plan. So for understanding, I have picked some simple plan. So this is the code base. Okay, I think this is visible. So this is a very simple query plan where you can easily identify two issues with this plan. One is it is going with external merge, and also you can see a sequential scan. So once you submit, it will start converting this plan into an embedding. It will search the vector database in the backend to get the context. Once it gets the context, it will again augment this embedding inside a prompt, context inside the prompt, and again it will send that prompt to an LLM and get the recommendations. Okay, so you can see that in few seconds it has read the plan. It has generated these recommendations. You can see the impact column, which means that this particular recommendation will have the highest impact on the cost reduction if you implement this recommendation. So need attention if there is some good to have recommendation, it will be false. And let's go with the first recommendation. It says to create an index to avoid that sequential scan. And it has also said recommended or informed that the tool can also eliminate your sorting once you create the index. So it also has some additional useful information. If you click here, it will display what part of the RAG or the document it picked to generate this recommendation. So let's also try with a query instead of a plan. So it also will store all the history of whatever you have searched. I am connecting to the sample database. So just to make it interesting, let me query a catalog table. Right, so it quickly connected to the database, got the plan of this. Again, you will see a difference in the recommendation here because we have instructed not to give recommendations when it's a catalog table. Usually with a default LLM, if you give this particular plan, it will ask you to create indexes or partition these catalog tables. Right? So we can, using the RAG or a prompt, you can also overcome the default behavior of your LLM. So this interface is doing a health check. It actually can connect to your database and read all the catalog tables based on your input. Let me show one. So this is a drop-down menu where you can perform various checks on your database. So let me check top 10 tables. So these are the tables which will have the highest traffic and most of the issues. So this will connect to the database. So if you look at the code base, you will not find any SQL queries in the code. So it will also, based on the input, it will also generate SQL query on the catalog tables. It will run those queries and generate the output. If you look at this data, what it has got, it's not just checking the 10 tables. It is also checking when it was auto-vacuumed by joining pgstat all tables and etc. Right? So it is getting additional information of these 10 tables to give better recommendations. So once it gets this data, it also sends this data embedding to the LLM model, vector database, gets the context, again sends the prompt to LLM to analyze this data. You can see it has suggested, concluded that there are some index blot on this particular table. So these are very useful recommendations. It has also recommended to optimize these settings for these 10 largest tables for improving the vacuuming. It also suggested partitioning. So, but for partitioning, it has given some recommendations how to analyze these tables, on what basis you can choose whether to partition or not. So it has also suggested pgpartment to create partitions for easy maintainability. So now you got these recommendations, but you're not aware how to actually perform these tasks, right? So for example, let's take this example. So now we will go to database assistant. So I'm skipping this because this is very specific to RDS cloud databases. So here we are checking whether the infrastructure on cloud was optimal or following all the best practices. So let's ask, so this is the interface, this is the chatbot where we can ask some questions. So it also has a streaming capability. So once you select streaming, it won't wait for the entire response to be received. So it will, as and when it receives the response, it will start printing this. So I'm just asking how to partition a table using pgpartment. Right, so you can see it's giving an example and the command as well, and it's also explaining each and every argument for these methods. So you need not go to multiple places to search for getting information. It is also giving extra information on how to create future partitions. So this is one solution where you can get recommendations, also get the detailed steps to actually implement it. So if you click on the source details, so you can see the score as well. So this score denotes from this particular document what was the nearest data which it received from the vector database. Based on this, you can enrich your knowledge base by giving it extra documentations. So for these AI tools, most of the time we spend is on enriching the data. So with this interface, you can easily upload and create new data in your vector database. So this was the first version of the tool. So there is a lot of room for improvement. And we are actually coming up with version 2 with some of these improvements. Yeah, so in the next version, we'll also have troubleshooting PostgreSQL log files. It will automatically read the log files and go through any errors or slow queries and get recommendation directly from the log files. And we're also trying to come up with conversational history, in the sense, let's say it has given a recommendation and you found some issue with that recommendation. You can also give a feedback, and it will take the feedback, and next time it will improve those recommendations. So we are also trying to leverage chain of thoughts in the prompting, where, for example, you gave a query plan. It has recommended you to increase the work mem to avoid external sort. By using a chain of thoughts, we are trying to actually go and check each and every table in that plan and its stats from the database, and also generate more meaningful recommendation or exactly how much work mem has to be set. Yeah, if you have any questions, you can ask.